that person that person might be stand there like this, right? Fifth position. So you can observe this end. That end is called rare. The rare end is used to insert the elements. If any new person comes, that person can add into this queue at this end. That end is called rare end. And inserting the elements into the queue is called NQ. NQ is represent the operation. The operation is used to insert the elements into the queue. NQ means insertion. DQ means deletion. Deletions can be done at the front end. Insertions can be done at the rear end. These are important points you must understand about the queue concept, right? Front, rear, deletion, and addition or insertion. What are the operations we can perform on queue? Just now we covered already, but anyway, let us go through this. NQ operation. The NQ operation is used to insert the element at the rear end of the queue. See now, this is the rear end. This is used to insert the element that is called NQ. DQ, the DQ operation performs the deletion from the front end of the queue. So this is the front end. Okay. We can delete these elements from the front end. That operation is called DQ. It also returns the element which has been removed from the front end, and it returns an integer value. The DQ operation can also be designed to void. Okay. So that is implementation purpose. So general terms are DQ is used to delete the operation from the front end. Next, peak operation. So we have the same operation in stack also, peak, right? So this is the third operation that returns the element which is pointed by front pointer in the queue but doesn't delete it. So DQ means DQ means the element and that to be deleted. Coming to the peak, the element pointed by the front pointer but that element will not be deleted. Just that is used to get the element only. We don't want to delete that. Just I want to print that. That operation is called peak operation. Queue overflow. When the queue is completely full, then it shows the overflow condition. So there is no space to insert the elements furtherly. That case is called overflow. Underflow. When the queue is empty, that is no elements are in the queue, then it throws the underflow condition. For example, every time coming to the implementation, generally what we do is, if you want to delete any element from the given queue, first we need to check whether there is an element or not, right? That's why we need to check about the underflow. If there is the underflow case, nothing but there is no element. No need to implement deletion operation, DQ operation. If there is no underflow case, nothing but there is an element, then you can go for the DQ operation. So this is how to implement the code. Then where we use queue in real world, queues are widely used as waiting list for a single shared resource like printer, disk, CPU. So in our real time, whenever working with the printer, we may identify that suppose you are giving the print of any particular document, and without getting that, or that might be in the process, if you give the printout of any second document, you may observe the queue, print queue. Okay, in the printer option, you can observe the print queue. So this is the real-time scenario where we maintain queue data structure internally for that. The printer application maintains queue data structure internally. First in will be the first out. Queues are used as buffers in most of the applications like MP3 media player, CD player, etc. Queue are used to maintain the playlist in media players in order to add and remove the songs from the playlist. So in the real time also, whenever you are listening the music with help of any media player, if you want to add the songs to that player, if you want to create your playlist, or directly if you want to add the any tracks, any music files to the media player, you can observe that media player also maintain the queue. First added track will be played first. Okay. So nothing but that also maintain internally queue data structure. Queues are used in the operating systems for handling interrupts. While working with the operating system also, different type of the interrupts may happen. So the operating system may solve these interrupts in the queue fashion. First raised interrupt will be solved first. The same formula will be followed by the operating system also. Next, we have different types of the queues. We'll discuss those one by one. First one is a linear queue. This is the general queue. When we use the word queue means that is linear queue in general. In linear queue, an insertion takes place from one end while the deletion occurs from the another end. Just now I shown to you an image now. That image is related to linear queue itself. The end at which the insertion take place is known as the rear end, and the end at which the deletion takes place is known as front end. Obviously, we discussed that already. It strictly follows the FIFO rule. FIFO is a short name for first in, first out rule. Okay. See this. For example, I have a queue and I have three elements. Let us say front end. Okay, is used to delete the elements. Rear end is used to insert the elements. By default, front value is 0, rear is -1. If you want to insert the elements, rear value will be incremented first, then insert the element. Okay, rear value incremented 0 and first value will be inserted, and again rear value will be incremented to 1. Then the element will be stored in the first index. Again rear value will be incremented and the element will be stored and so on, like this. So the above figure shows that the elements are inserted from the rear end, and if we insert more elements in the queue, then the rear value gets incremented on every insertion, right? If you want to show the deletion, then it can be represented like this. Delete means front. When you increment front, that comes from 0 to 1. Whenever it comes from 0 to 1, that 0 element will be deleted. So this is how front works. Okay. Front is used to delete the elements. Rear is used to insert the elements. Increment the front pointer value is indicate delete the elements. Increment the rear pointer value represent insert the elements. We can observe that the front pointer points to the next element and the element which was previously pointed by the front pointer was deleted. Just now we covered that, right? When the front pointer pointing to the index 1, automatically the pointer value is 0. Previously, the index value is 0. That value will be deleted automatically. The major drawback of using linear queue is insertion is done only from the rear end we covered. If the first three elements are deleted from the queue, we cannot insert more elements even though the space is available in the linear queue. So in this case, the linear queue shows the overflow condition as the rear is pointing to the last element of the queue. And for example, let us say we have the queue like this and rear is incremented, rear comes here and finally rear reaches to this point. When if you store, for example, 40 here and you can store 50 here. So now this is the rear position. Okay, rear position is this one. Now front is at index 1 and this is deleted already. And whenever rear reaches to the last element, that shows overflow condition. Okay, nothing but there is no chance to increment the rear value because there is no cell here. We cannot increment the rear again. That shows overflow condition. No chance to insert the element. But if you observe, there is a empty space here at the 0th index because we incremented the front. So a element is removed from here. Okay. And there is an empty space at the 0th location, but it shows the overflow condition. Even though the empty space is available in the linear queue, we cannot store the elements. We cannot utilize that empty space. This is the major drawback of the linear queue. Okay. This is what we covered here. The major drawback of using a linear queue is that insertion is done only from the rear end. If the first three elements are deleted from the queue, three or two or one, whatever it might be, we cannot insert more elements even though the space is available in the linear queue. In this case, the linear queue shows the overflow condition as the rear is pointing to the last element of the queue. So this is what we covered just now. Let me tell you the behavior of the rear and front pointers to get good idea about the queue uh, architecture. Rear increments when inserting an element. Always rear pointer value will be incremented when inserting the element. Rear never decrements in linear queue. If rear reaches the end of the array, the queue is full. Even if there are empty spaces at the front. We covered this case just now, right? Whenever the rear reaches to the last position ending point, that shows that there is overflow condition, even though the space is available in the front. Front behavior, front increments when removing an element. Rare increments when inserting an element, front increments when removing the elements. Front never decrements in the linear queue. If front cross rare, if the front pointer crosses the rear pointer, the queue is considered empty. There is no element in the queue. Next, circular queue. Just now we covered the drawback with queue. Even though the memory space is available, we cannot insert the elements because already rare reaches its maximum position, last position. Now, to overcome that problem, we have another type of the queue called circular queue. In circular queue, all the nodes are represented as circular. These are the nodes. Okay. In the previous scale, we use cells. Na? Those are also called nodes. The circular queue is similar to the linear queue, except that the last element of the queue is connected to the first element again. Observe here. This is the last element position, again connected to the first position. It is also known as ring buffer, as all the ends are connected to another end. We have two ends here. So last element again connect to the first element, first end. That's why it is also called ring buffer. It looks like a ring. The drawback that occurs in the linear queue is overcome by using the circular queue we covered. If the empty space is available in the circular queue, the new element can be added in an empty space by simply incrementing the value of rare. Now see, so this is the circular queue. We inserted the elements like 1, 3, 5, 7, 9, 11 elements we inserted. Okay. And we have some empty spaces. Let us assume that these elements are inserted and removed. Okay. And now rare is at this position. So in this case, as we have an empty space, we can utilize this empty space by incrementing the rare value. Increment the rare value, rare points here, and you can store the elements here. Again, increment the rare value, store the elements. Like this, we can utilize the memory efficiently in the circular queue compared to linear queue. So this is about two important queue types. Let me show you the implementation of these two using Java. So this is the code which is used to implement a linear queue. And here I am using the IDE VS Code. You can execute the same code without VS Code also, but this is has a good flexibility to write the code and execute the code. First, I am creating a class. Class name is linear queue. And within the class, creating variables to store the data. See, in the third statement, I am creating array, private integer array. ARR is a array name where we can store integer values. So third statement is used to create the array. Fourth statement is used to declare three variables called front, rear, capacity. All are intertype only. Front is used to indicate the front pointer. Just now we covered front, okay, which is used to remove the element, that is one end. Rear is the another end that is used to increment the values or insert the elements. Capacity is used to what is the actual capacity of that queue. To store that, I am using the variable capacity here. For example, the actual capacity of the queue is 8. Okay, that might have 8 members. Even though the capacity is 8, we may have 6 element also, right? So capacity is complete strength. How many elements can we store? Next, sixth statement. This is a constructor because this method name and our class name is same. It has one argument. The argument is intertype size. The size will be passed when we create the object to this class because this is a constructor. Constructor will be executed when we create the object for the class. So at that time, we need to pass the size for this constructor. Okay. For example, as per our code, see here, we are passing 5. Okay. This is the main method, creating the object for the class linear queue. At that time, we are passing 5. This calls a constructor, parameterized constructor, and it passes 5 to the constructor. So it redirects to the constructor where we have in our code. So here we have the code. Now size value becomes 5. What is size? Size, how many number of the elements you want to store. Okay. The maximum capacity is indicated with the variable capacity. But now I want to store only 5 elements. Size is nothing but how many elements we have. 5. Okay. So with this size, I want to create a new array, new keyword int capacity. Okay. Because this size is assigned to this capacity na 5. So with the capacity 5, a new array is created. And after creating the array, front is created with default value 0. Rear indicates -1. By default value is -1. Now, I'm writing some more methods to check the different cases. As we cover the different cases, we have empty case, that is underflow, full case, overflow case, and insertion, deletion. Okay. For all is peak. For all these, we are writing different methods. See, first method, public boolean is empty. Method name is empty, and it is a boolean method that might returns true, either true or false. Return front greater than rear. If front is greater than rear, in this, depending on the case, that may returns any boolean value depending on the values of front and rear. Okay. When front value is greater than rear value, generally we can understand that the queue is an empty. Always front value is less than rear in general whenever you have the values elements in the queue. When front value is greater than rear, that indicates there are no elements in the queue. There is an empty. So based on the values of front and rear, that will be decided. E is full. This is also Boolean type that returns either true or false. It returns rear is equals to capacity minus 1. Nothing but rear reaches to the last position. Capacity means, for example, 5. The index value of that fifth node is 4. So rear equals to 4 means it reaches the last position. So in this case, it returns true. Nothing but in the is empty case, it returns true when the queue is empty. When we call is full, it returns true when that is full. When the queue is full. When the rear is indicating last index position, that indicates the queue is full already. So in that case, is full method returns true. NQ, inserting the element, we'll call this method by one value and that value will be stored in the variable item. That value I want to insert into the queue. If E is full, we are calling the E is full method. Okay, because before inserting the element, we must know whether there is an empty space or not. If it returns false, so there is an empty space. If it returns true, this 26th statement becomes true. If statement returns true, the control enters into the if block and the printf output statement will be executed and we will get the text like queue is full, cannot enqueue. Queue is already full, you cannot insert any element. This type of the text will be printed. Then it comes out from the function enqueue. When if it is true case, if it is false case, means it is not full. There is an empty space. So we can insert the elements. In that case, first we must increment the rear position. As we covered, rear is minus 1 by default. So in the first position, now I want to insert the element. Rear becomes plus 1. Minus 1 plus 1, nothing but 0. Rear indicates 0 position. At the 0th index position, the first element will be stored. See what is the item we passed. That item will be stored at array of 0 position in the first iteration. Next, coming to the DQ operation, we are writing one more method. If is empty, checking whether that is empty or not. If it returns true, that returns either true or false, depending on the values of the rear and front. Just now we covered the code, what we have written in is empty. If is empty returns true, nothing but the queue is empty. Then 36th statement returns true. That's why the controller enters into the block. And within that block, what is the code we have? System.out.println. Queue is empty. You cannot delete the elements. There is no element to be deleted. Or you can write cannot dequeue simply. Right? And return minus 1. The value minus 1 will be returned. If this returns false, nothing but that is not an empty. Now you can go for the delete operation. There are elements. You can remove the elements. For that, I'm writing the code return array front plus plus. So as we covered just now, if you want to remove the elements, just increment the front value. So automatically the element will be removed. Suppose front indicates 0th index value. If you write front assignment front plus 1 or front plus plus, front value becomes 1. So the element which is available at 0 previously that was removed. And this is closing point of DQ. Next operation, peak operation. So we covered theoretically already what is peak, what is the use of peak. Peak operation is used to access the element without deleting, right? Within the peak method, in the 46th statement, observe if E is empty. And before going to access, we must know whether there is an element or not. That's why we are calling the is empty method. If it is true, there are no elements. So if there are no elements, how can we access that? So no need to execute the access related element, access related code. So if it is true, control enters into the if block and the text message will be displayed. Q is empty and it returns from the peak. No statement will be executed in the peak method. If this is false, the control will not enter into this block. It directly comes out of the block. 51 statement. If this returns false, directly control comes to the out of the if block, that is 51 statement. Return array of front. So what is the value we have pointed by the front pointer, that is first element, that will be printed without deleting. So this is how to access the element without deleting, that is peak operation. Next, display operation. Before displaying that also, I'm going to check whether that is empty or not. If it is empty, no need to display, no need to continue the execution of the code. If that is not an empty, then you can go for the next code, which is used to display the elements. See, system.out.print Q elements are just as a headline, head just like a heading, we can write the text Q elements are. And 62 statement, we are writing a for loop. As we covered, start with front, okay? And last value is less than or equals to rare, because actually that is index value. Rare equals to 5 means index value ends with 4 only. That is the reason why we are writing less than or equals to rare. And every time the I value becomes incremented. System.out.println array of I. Okay. Front value, first front value, that whatever the value we have in the I, that value will be printed. Like this, from first to reaching to the last rare point, each and every element will be displayed. So for good readability, just I am creating an empty line with help of the system.out.println. Now see the main method, public static void main string args, as usual as per the Java standards. 71 statement, creating the object for the class, and where I am calling the parameterized constructor and passing the value 5. Now this 5 value will be passed to the constructor. This is the constructor, and we are passing the size 5 now. So 5 elements sized queue is created. Okay. After that, I want to call enqueue method to insert the elements. Enqueue, enqueue, enqueue. 3 times I called enqueue method, and 3 elements I stored are 10, 20, 30. Okay. And these values are stored in the item variable. After that, in inserting, I want to call display method. Okay, I want to check whether the elements are inserted or not. So in the display method, we have written the code already to display the elements. After that, system.out.println dequeued. Nothing but I am going to implement a dequeue operation. We are giving that information. Concatenated with q.dequeue. So we are calling the method dequeue for the deletion. So we know that already. It follows first in, first out, FIFO. So first inserted element 10 will be deleted first. To prove that, again, I want to display the Q values. In that, we must have only 20, 30. First in, first out. And I want to call Q.peak method to access the front element without deleting that. Okay. So these are the operations. Probably all the operations we implemented here. Let me execute this. Yes. See, Q elements 10, 20, 30. So we created a queue and we stored the elements 10, 20, 30. After that, I call display method. Na? That's why these elements are printed 10, 20, 30. Then dequeued 10 two times. I think it is. Now, dequeued 10. So I want to remove the element first in, first out. That's why this is the first element na, that was removed. And for the clarification, again, I call the display method. Now we have the elements 20, 30 only because first inserted element is removed. Next, I implemented a peak method. So peak method is used to access the front element without deleting. Front element is 20. So I want to access that. So 20 is printed without deleting that. Okay. So this is how to implement queue with all operations. That's it. Now, next code. This is about circular queue. Just now we covered theoretical concept about circular queue. Now we covered the drawback of the linear queue. Even though the space is available, we cannot insert the elements. To overcome that problem, we can use circular queue. Now, how to implement circular queue? See the code. Class, I'm creating a class and empty array, creating an empty array without specifying the size and creating the four variables front, rear, size, capacity. Now, this code is similar to the previous code, except few changes. I'll focus on the changes also. Now, this is a constructor. Observe, class name is same as this method. So this is a constructor. It has one parameter. So it is a parameterized constructor. We need to pass some value at the runtime. Depending on that, a circular queue is created. For, for example, so I passed 5. Okay. Capacity value is 5. So this dot capacity equals to capacity. So when we have the same name for the instance variables and parameter name, we can use this variable. We covered that in the Java concept. And based on that, we can assign the value of capacity. And based on that capacity value, we are creating the array. Front value is 0 by default. We covered just now in the previous example also, same logic. Rear equals to -1. Size equals to 0 means in this case, available elements. Okay. By default, available elements are 0. For that, we are using the variable size. As this is a circular queue, we can utilize the empty space also. Now, coming to the is empty, see now, public boolean is empty, return size is equals to 0. So, number of the elements available in queue is equals to 0. In this case, that returns true. Return true. This value becomes true when number of the elements size is used to indicate number of the elements available in the queue is equals to 0. No elements. It returns true. Okay, that is empty case. Full case means return size equals to capacity. Okay, capacity is 5 and 5 elements are available. That is size. Okay, total capacity represent capacity. Size equals to how many number of the elements available at that particular point. That is represented with the help of the variable size. Okay, I created 5 cells. That is capacity is 5 and I stored 5 elements. Size equals to also 5. So this is true. So there is no space. 5 cells, 5 elements. So that is full case, na overflow case. So it returns true when we have 5 elements and we created 5 cells. There is no space available. Okay, that is full. So observe here. Here I am not considering rear value and front value because even though the rear value might be indicate to the uh, greater position last index value, but we can utilize the existing memory. That's why I'm using a extra variable size here. Okay. Then public void enq same is full. First we need to check it is full or not. If it is full, we need to print the message q is full already and return keyword is used to exit from the method. If this is not true, in that case, this is important point here. So in the previous case, in the linear queue, just we incremented the rear value and we store the item. 1 minute. I will show you that. See this. In the case of false case, full case is false. First, rare value is incremented, then we store the value in that, right? But coming to the queue, we need to increment and we need to wrap up that queue because this is circular queue. If there is any space, we need to continue. We need to wrap that for the next cell also. That's why we are writing the code like rare plus one modulus revision capacity. So this is important point. This is the difference, major difference compared to the linear queue code and circular queue code. Okay. Then, so we can store the item, whatever we received in the rare position, incremented rare position. So we added one element. That's why the size will be incremented, where size is used to indicate number of the elements. Next, DQ. Before implementing the DQ, selecting whether there are an elements or not by using isEmpty method. If it is true, it is displayed empty method and returns. It is false. If it is false, it's going for the DQ implementation. Okay. And we are going to get the value which is available at the front position and I assigning that value to the item and front value becomes front plus one modulus division capacity. And as we deleted one value, size becomes minus minus. And what is the item deleted already from the front? We stored in the variable item. We want to return that because I want to print like this element is removed. Next, peek without deleting accessing. So first we are checking whether there is an element or not. If it is empty, that indicates there is no element. So if it is false, it comes to the front case. What is the element available in the array at the front position? And that will be returned with help of the keyword return. So display method as usual, same logic. Before displaying, I'm going to check empty case. If that is not empty case, there are elements. So if our elements, create the loop and print the each and every element. Main method, create the object for the class and pass the parameterized constructor argument value. Add the items 10, 20, 30 and display the queue. After that, delete the first element, DQ. Again, display. Again, peek. Execute it. See 10, 20, 30 DQ'd. So first inserted element will be deleted first. So the remaining elements will be displayed 20, 30. So peek element to access the first element without deleting. So first element is 20. We can access that with help of the peek operation. Okay. So that's it about queue and types of the queue, linear queue and circular queue, and implementation of a linear queue and a circular queue with Java. So that's it for today's session, and we'll continue that in the next session. We'll cover one more type of the queue that is called priority queue. After that, we'll start linked list concept also, right?